environmental engineering. So I have been working on several water and wastewater treatment plants in mostly in Pakistan. So and also I was lucky to install some MBR plants. So today meeting is all about membrane bioreactors, MBR, and now I'm going to share my screen. Sorry, organizers, I'm a bit struggling for sharing the screen. Can you guide me? प्रेजेंट नाउ का ऑप्शन है, जब हम प्रेजेंट नाउ पे जाते हैं तो वो फर्दर ऑप्शन देता है, बट उसमें शेयर का ऑप्शन प्रेसेबल नहीं है. देन आई गो टू स्क्रीन, वहाँ पे शेयर और कैंसिल का ऑप्शन है. शेयर का जो बटन है वो प्रेसेबल नहीं है. शायद आपने राइट्स नहीं दिए होंगे मे बी शेयर स्क्रीन के. Okay, now I found the problem. No problem. I can. You can see my slides now? Okay. Thank you and sorry for inconvenience. Okay, let us start. So today our topic is membrane bioreactor for wastewater treatment and reuse. Right? And then we will introduce MBR as a cutting edge technology for wastewater treatment. And then the history of MBR in the world, in Pakistan, and potential research areas in MBR. I have considered these list of contents, keeping in view that we have some youngsters and students who are attending this conference along with the experts as well. So for students, we need to tell them that what are research areas and what is their future if they do research. So what is their future in the market? So first of all, water issues in Pakistan. These three photos taken from Pakistan present three main problems. One is water availability. Second is water quality. And third is water accessibility. Sometimes water is available but not accessible. Sometimes it is not available. And sometimes its quality is very down. So we are facing, unfortunately, all these three kind of problems in Pakistan. We are already underwater scarce nations. So if a country has between 1200 to 1700 meter cube of fresh water available per person per year, then they are called water stressed country. And if this value is less than 1000 meter cube per person per year, then they are called water scarce country. And up till now, we are already under the water scarce limits. So that's a big problem for Pakistan, because one of the reason is, of course, overpopulation. We are now the fifth largest populated country in the world. A bit about water quality. What would be the problem if we use this type of contaminated water? For certain inorganic contaminants, like if we have higher levels of aluminium in our drinking water, so or potable water, it can cause neuropathological disorders. Similarly, arsenic can cause serious skin issues. And similarly, many other metals and heavy metals can cause different problems. Similarly, organic contaminants, first of all, the biggest problem with organic contaminants is that they give a nuisance to the water. They give a color, they give a taste, they give an odor. And as a human being, you cannot consume water which have either color or taste or bad odor. So inorganic contaminants are latent. They generally don't give any color, taste, or odor, but organic contaminants, they give color, taste, and odor. So they are also like carcinogenic, and ultimately they become a part of food chain. What is the wastewater disposal practices currently going on in Pakistan? If we see, our biggest city is Karachi. Karachi is dumping the most of its untreated sewage or wastewater. We will use these terminologies off and on. Sewage we generally call for domestic wastewater, and wastewater we also use term for industrial as well as domestic wastewater. So Karachi is dumping the wastewater into Arabian Sea, Lahore in Ravi River and irrigation canals, Faisalabad again in Ravi River or Chenab River, and you can see. So unfortunately, up till now, we have only city level wastewater treatment plant in Islamabad, and maybe now in Gilgit it is under preparation. And others are like planned and designed, like for Lahore, there are projects in which they have designed, but on ground, not so far. Our national water policy of Pakistan was approved in April 2018, not very long ago. So national water policy states at least at 4 to 5 different places that reuse the treated sewage for domestic purposes, for agriculture purposes, for industrial purposes. So it emphasizes more on the reuse of treated sewage. So how to treat that sewage? That's a question. How to treat that wastewater and reuse it? What the world is doing? It is the treated wastewater for reuse in billions of gallons per day. So USA is reusing the most of its wastewater, about 2 billion gallons per day. Similarly, Saudi Arabia, Egypt, Israel, you will see, and all other countries. So global reuse of treated wastewater is about 5.5 billion gallons per day. So if all other countries can treat and reuse, we should also think about treat and reuse. Biological treatment of wastewater. Wastewater can be treated by physical ways, chemical ways, physicochemical ways, as well as biological ways. Up till now, biological treatment of wastewater is the most common methodology for wastewater treatment in the world. Till date, about 70% of the treatment plants are based on biological treatment processes. Reason: number one, its operational cost is less compared to physical or physicochemical or chemical processes. Secondly, the sludge which is generated as a byproduct of wastewater treatment. One is the product water which you reuse, and second is the sludge. So the sludge is stabilized. It is no more hazardous for the environment when you use biological treatment. That's why biological treatments are one of the most common treatment techniques used in the world. What is the concept of biological treatment? We use bacteria here to serve our purpose, to treat the wastewater. Okay. So like human beings, bacteria also need three things, which are air, water, and food. If bacteria can get these three things, they can survive, they can grow, they can reproduce. Okay. So air in biological treatment, mostly in aerobic treatment, we provide using mechanical blowers. Water is everywhere in the wastewater. And food are those contaminants, particularly the organics, which bacteria can utilize as their food. And bacteria can eat them as food and grow and reproduce and increase their number. And after, like I said, that bacteria are also like human being, ultimately they have to die. Every living thing has to die someday. So after spending their 5-7 days life, the typical aerobic bacteria dies. And it's no more harmful, like a dead man is no more harmful for any other. Okay. Activity sludge process is a very common wastewater treatment process used in the world. It's one of the most common biological treatment process. So what is that process? We are seeing a tank filled with brown color, and we see air bubbles, air diffusers at the bottom. So aeration is going on, and the brown color is of sludge. Sludge means bacteria plus the wastewater which is coming inside the tank. This tank is called aeration tank. And after aeration tank, all this sludge and treated wastewater goes to the clarifier where it settles at the bottom. We give it a retention time, for example, 1 hour, 2 hour, and the sludge settles due to gravity, and it is recycled again into the aeration tank, and the treated water, which you can see in the blue color, and depending upon the quality of inlet wastewater, this treated wastewater can be used, reused, or not reused, or simply discharged into some water receiving bodies. Now, what was the problem? Problem with activity sludge was, you will think when I say that bacteria can grow here in the aeration tank, if, for example, we have 2000 milligram per liter concentration of bacteria in the tank, they can, let's suppose, consume the COD in the wastewater in 5 hours. If we double the concentration of bacteria in the aeration tank from 2000 to 4000, then they will take less time, maybe 3 hours, to consume the same amount of COD in the wastewater, because now there are more bacteria to consume the same amount of COD. So what ultimately we will want? We will want something like unlimited concentration of bacteria in the aeration tank. We may want 10,000 milligram per liter, okay? But what would be the problem? More bacteria we have in the aeration tank, we call it MLSS, mixed liquid suspended solids. So higher the MLSS concentration in the aeration tank, bigger will be the problem for their settling in the clarifier. The clarifier will start getting more solids, and this brown color which is settled just in the bottom may come up to the top. And even in the treated effluent, you will start finding the suspended solids or sludge particles or the dead bacteria. So that's the problem. Due to that limitation, we cannot go above generally typically 2500 to 4000 milligram per liter of MLSS concentration, mixed liquid suspended solid concentration, in the aeration tank. There are different type of bacteria: stragglers, good settling, pin flock. We cannot have a monoculture in the aeration tank. It could be a mixture of 10 different bacterial species. It could be a mixture of 100 different bacterial species. Definitely there are some dominant species which are more available, or their percentage is higher in the mixed activity sludge, and some are lesser. But we want good settling bacteria so that they can settle in the clarifier later. And if we increase the concentration of bacteria, we see, if you see here, F over M ratio in the middle. F means food, M means microorganism concentration. So if your food is less and microorganisms are high, so F divided by M would be a very lower value. And you will see here nematodes, ciliates, pin flocks. which are not good settlers. They will in any way go outside the clarifier untreated and increase the TSS of your effluent. So that is why we need some solution which is free from settling type of issues. Okay. MBR. Now we come to our topic, membrane bioreactor. So MBR removed these kind of problems. We see here two trains. One is conventional activity sludge and below is membrane bioreactor. In conventional activity sludge, we have wastewater coming to the primary sedimentation tank, flotation tank, aeration tank, disinfection, and then clean water supply. So all these four tanks are combined in a single tank in membrane bioreactor as shown in the left bottom figure. This is the aeration tank like I showed you in the activity sludge process. Aeration is provided with the help of diffusers and aeration blowers. So aeration serves two purposes. One, it provides oxygen for the bacteria to survive. And second, it keeps the sludge in suspension in a mixing so that there is no short circuiting. Every drop of water, wastewater, which comes inside the MBR will get some type of treatment at least. It will be mixed with the bacteria. So aeration serves these two purposes here. And there is an anoxic chamber as well, which is optional. In some MBR, we provide anoxic mixing with the help of a mixer. No aeration is provided. And in some MBR, we don't provide anoxic mixing. But generally, nowadays, people do provide anoxic mixing. And then you see the membranes, these blue color tubular membranes. You can see the pores on the membrane surface. So pores are so small that only the water molecules can get inside the membranes and all the sludge particles and suspended particles are removed or stopped by the membrane mostly due to size exclusion process. So these membranes are operated on a suction pressure. There is a treated wastewater pump which is like sucking the water from the membranes, and due to a negative pressure or suction pressure, only the water can enter in the membranes and all other contaminants are stopped. So if you see, now the problem of clarifier has been replaced with this membrane. So instead of a clarifier, now we have a membrane, and we don't have any problem that either the bacteria is good settling or bad settling or pin flock type, because in any way it would be stored by the membrane. Okay. So now we can maintain a higher concentration of bacteria or MLSS in the aeration tank. And typically in a membrane bioreactor, one can go between 8,000 milligram per liter to 15,000 milligram per liter MLSS concentration in the aeration tank. So due to very high concentration of MLSS, now the work which your conventional activity sludge treatment was doing, for example, in 7-8 hours, this MBR can do in 4 hours or 3 hours. Okay, because you have now more bacteria to consume the same amount of COD from the wastewater. So that's the process of MBR. Okay, now we are free from the settling problems. What are the advantages of MBR? You can see in the bottom right, there is a beaker with water. It's the treated wastewater ready for reuse from an MBR plant that was installed by us. So less time required for treatment, as I showed you, because we can maintain a very high concentration of MLSS or bacteria in the aeration tank. So we need lesser time. When we need lesser time, it's mean we need smaller tank. Okay, if we have, for example, same volume of wastewater, 100 meter cube of wastewater to be treated through aeration activity sludge process and same amount of wastewater to be treated through MBR process, we need a smaller aeration tank in MBR. So smaller tanks mean less space requirement. Excellent treated effluent quality, no doubt. Treated effluent is, if I don't tell you that it is a treated wastewater, you will consider it like a tap water. And it can be operated at very high MLSS concentration and no need of clarifier or flocculants required. But there are also some disadvantages of MBR on which research is going on to solve the problems. High automation requirement because it involves membranes. So Membranes require maintenance as well, and automation of softwares. At what time you need to have a suction pressure on the membrane so that you can get water flux through them. And then membranes also need a backwash, and occasionally they need a chemical cleaning. So of course you need to have a high automation requirement for the membranes. And yes, higher operational cost, which we call as a specific energy requirement, which I will also show you in exactly the values in the next slides. The dollars per meter cube of treated wastewater compared to conventional activity sludge process. And of course, high maintenance requirement. So now we talk about the integral part of MBR, which is what type of membranes are used in the MBR. Okay. There are four types of membranes. MF mean microfiltration, UF mean ultrafiltration, nanofiltration, and reverse osmosis. Microfiltration membranes have pore size of micrometer, generally 0.1 micrometer. Ultrafiltration have 0.01 micrometers. Nanofiltration goes to 0.001 micrometer or 1 nanometer size of pores. And reverse osmosis go to attometer or zero point 0.1 nanometer pores. You can see they have tried to show the pore size with the help of patterns which are getting smaller and smaller when we move from MF, UF, NF, and RO. So basically the membranes work mostly on the physical phenomena of size exclusion, but also the membranes are made for specific jobs, so they can serve as a physical as well as physicochemical phenomena. Sometimes membrane has some active layers which are coated on the membrane surface to remove certain typical contaminants. For example, if you want to remove some iron with the help of membrane, if you have very high iron dose, so you can do some specific coatings. So they will generate active groups on the membrane surface which can capture iron. But most of the time membranes are a physical phenomena and they just do the size exclusion principle. They work on that. So from microfiltration, you can remove suspended solids. From ultrafiltration, even you will see that along with suspended solids, your bigger organics would also be removed. With nanofiltration, you can even remove multivalent ions. And with RO, you can virtually remove everything except water molecule. But generally in MBR, we go with ultrafiltration or maximum nanofiltration. We don't go for RO or MF generally. Membrane fouling. So first thing which comes in anyone's mind when we talk about that every other thing has been stored by the membrane except the water. So where does that every other thing went, which was there in the activated sludge? Okay. So all other contaminants which were stored by the membranes, they start to foul the membrane surface. So fouling could be of several types, which we'll explicitly discuss in the next slides. Number one, the bigger foulants can just accumulate on the membrane surface and form a layer. So that is, you can call it a scaling layer or a fouling layer. Okay. Also, the smaller particles which are near to the membrane pore size, they can try to get inside the membrane pores, as shown in here. In some pores, the smaller contaminants are trying to enter. Okay. So they can cause an internal fouling of membrane when the pores are fouled from inside. So internal fouling is considered a bad type of fouling compared to external fouling or a fouling layer or a scale layer formation. Okay. This can happen to a membrane which is under use in a membrane bioreactor after, of course, several number of years. It's not after a few days. Generally, up till now, people believe that a membrane can work from 3 to 5 years easily. So you see there is severe internal fouling and scale layer formation, and they have also provided a scanning electron microscope image of the fouling. So you can see the foulants accumulation. So what fouling do? Fouling reduces the flux, of course, because the pore size, many of the pores are covered on the membrane surface. So your flux, for example, if you were getting 100 liters initially from the membrane, periodically it will start decreasing due to fouling to 90 liters, 80 to 70 like this. And then it causes a membrane damage because most of these contaminants can be, although membranes are generally polymeric membranes, and they are like polymers which are not reactive, but even then some kind of bacteria or some kind of species or some kind of contaminants can damage the membranes, although the polymers are inert. So for getting the same flux, you need a higher energy consumption, and membrane requires cleaning. And more you clean it chemically, it reduces the membrane life. Like if we start washing our clothes again and again every day with surfactants, of course, those clothes' life will decrease. And in some cases, it can, if you have a severe fouling of the membrane, it can reduce the effluent quality. You will not get effluent like I showed you on the photo. So how to operate MBR? There are generally two ways the MBRs are operated. One is called a constant TMP mode, and one is called a constant flux mode. Okay, TMP is transmembrane pressure, mean how much pressure we apply on the membrane to get a flux. For example, I said that I want to apply a pressure of 50 kilopascal on the membrane, and I will keep it constant. Like if you see in the left graph, the TMP line is constant. You are applying a constant 50 kilopascal pressure on the membrane. So what will happen? So flux will continuously reduce, as we discussed in the previous slides, because of fouling. So initially you can get a higher flux, and with passage of time, the flux will eventually reduce. So second type of operation is a constant flux. You don't say, you say, okay, I will keep on increasing the pressure on the membrane surface, transmembrane pressure, but I want a constant flux through the membrane. I want, for example, 10 LMH flux, 10 liters per meter square per hour flux. So in that case, you will get a constant flux, but to get the constant flux with fouling membranes, you need to constantly increase the transmembrane pressure. So membrane manufacturers always give you extreme value up to which your membranes can be operated. And after you reach that extreme value, you have to stop the operation and you have to do backwash or chemical cleaning. As we discussed in previous slides, consider these are the contaminants. This green is the membrane of a membrane bioreactor. So all the contaminants, you will see most of the contaminants are stopped on the membrane surface, which is called external fouling. And some contaminants, due to their smaller size or shapes, they can enter the membrane pores and cause internal fouling. So one way to remove fouling is backwash. You apply a pressurized water flux. So initially, water was going from left to right. Now you applied a treated water from right to left. So all the layer which was on the membrane surface would be dislodged, and that will start flowing again, and you can waste this water. But backwash cannot remove internal fouling. Internal fouling is still there. It can only remove the external fouling or the surface fouling or the layer formations. There are some other methods to remove the fouling. One is called relaxation and one is called scouring. What does mean by relaxation? You see here filtration for 7 minutes. It means that your MBR is operational for 7 minutes. And then relaxation for 1 minute. For 1 minute, you have automated your system that all the pumps which were creating a suction pressure inside the membrane loop, they will be stopped. So your membrane pores would be relaxed. So once a thing is under pressure, more contaminants are sticking over it. And once you relax it, the contaminants will fall down. So that's the concept of relaxation, that for certain time period, the membrane is under operation, and then for certain time period, you stop the operation. It's very simple, and it is well practiced in most of the MBRs. And second thing is scouring. They have shown you a membrane lumen, okay, inside a membrane. So consider these brown foulants which were trying to enter the membrane, and then they are on the membrane surface. Then you provide membrane scouring. The scouring is done either by airflow or by physically moving the membrane. So what the airflow do, like I said, that we are doing aeration in the aeration tank of MBR. So that air can dislodge these foulants from the membrane surface. And you can see in this figure that these membrane lumens are flexible. They can move a bit. So they are designed for this purpose, so that when they shake, the layer can fall down. So all these methods of backwash, fouling removal, relaxation, and scouring are mostly for the scale layer deformation. But for internal fouling, we have to go for a chemical cleaning. What we do, we take the membrane and immerse it in a chemical solution for some time, and then internal foulants can be removed through the diffusion process. But the demerit of this is you have to maybe shut off your plant for 8 to 10 hours, or you can do it inside stream configuration as well. But this is something which you do only maybe once a month or once in 2 months. So chemical cleaning is not that frequent like backwashing or relaxation or other ways. Okay, so after giving you an idea of about what MBR is, what type of treated effluent it can generate, now we go to MBR history in the world, how MBR were developed. So they are very old in the market. From 1960 to 1970, first MBRs were developed using ultrafiltration and activated sludge, ultrafiltration membranes and activated sludge process in a side stream configuration. So side stream and submerge is in which membrane is submerged inside the aeration tank, and side stream means membrane is not physically submerged in the aeration tank, but you circulate the sludge, and there is a separate membrane tank where the sludge gets filtered and come back. So these two type of configurations are used in MBR. So you can see the Japan government basically spend more money in the R&D, and some professors, they were initially in the favor of submerged MBRs, and they installed very small plants, pilot plants of 25 meter cube per day at Hiroshima. And then some big companies like Kubota and Mitsubishi, they jumped in. So that is very important point, which we also will discuss at the end of presentation. So when these companies jump in, they started extensive research and development, R&D on MBRs, and then they installed several treatment plants all over the world. These are a bit old graph, but will serve the purpose to you. These graphs are from 2000 to 2012, and you can see the global market value in million of dollars reached roughly 1,000, mean $1 billion by 2012. And the same MBR market is expected to go up to 4.2 billion US dollars by 2024. So there is a huge potential for jobs in the MBR market, because, and why is that so? The reasons I have given at the bottom of the slide. Reasons are scarcity of water, global population is increasing, stringent environmental regulations in each and every country. The environmental regulations are getting tighter day by day. And space limitations. The land price have increased many folds in the last few decades. So now no more bigger lands are available for installing wastewater treatment plants. And no industry or clients or housing societies or hospital want to waste their land on wastewater treatment plants. So they want a compact solution which use less space. So due to all these reasons and also the technological developments, the MBR market is blooming. Number and capacity of MBR plants in the world, with the, if you see, they are the biggest companies like Kabuta, Torre, Vise, Hubbard, and Noret. They have installed several treatment plants and their capacities are increasing. So MBR plants up to now, the biggest are like 2000 meter cube per day. So these are very huge flows. So many big companies are jumping in the research for MBRs. Role of R&D in increasing the acceptability. The first question which comes in mind of students specifically and also the professional, that if MBR is a very good technique, why it is not accepted so far, well accepted in Pakistan and in most part of the world. So one thing was, of course, its operational cost, which we will discuss in the next slide as well. So by the use of, you will see number of installations of MBR has substantially increased from 2000 to 2011. For example, you can see up to very big plants are also installed and small plants, and totally you can see maybe hundreds of plants in a single calendar year. And here I have added number of research papers on MBR in different like MBR fouling, membrane cleaning, clogging, hollow fiber membrane, flat sheet membrane, hybrid process combining MBR with other processes, and micropollutants removal. Kept on increasing. When R&D increases, it fills the research gaps, and the industry, which I showed you in the previous slides, they can make decisions and they can make new products. There could be patents which they can convert into products, and that results in increase of acceptability of MBR in the world. So energy consumption in MBR. You will see in the right graph, the MBR system, which used to take somewhere 2.7 to 2.8 kilowatt hour per meter cube of treated water, has reduced due to R&D, generation of different type of membranes, reducing the blowers cost, operational cost. So from 2.7, 2.8, it has reduced up to somewhere 0.6 to 0.7 kilowatt hour per meter cube. Similarly, for conventional activity sludge system, which is most common biological treatment system, this cost has also reduced due to different processes, improvement, and it has gone maybe 0.1 or zero point 0.2 kilowatt hour per meter cube. So the gap which was initially there between MBR and activity sludge process has definitely reduced. And when energy gap is reduced, then of course its acceptability in the market will increase. So there is still a margin so that we can bring that gap further down or close to conventional activity sludge process. So this pie chart gives you that what things takes most of the energy from the MBR. Is it the feed pumps, the blowers, which are used for aeration and nitrification, and then you have permeate pumps, and then you have automation and everything. So most of the energy is taken by the blower. If you see 36% plus 17% blow, 53%, like more than half of the energy is just taken up by the blower. So that's the area of one of the research where we can do something, and we will discuss it. MBR history in Pakistan. So first lab scale MBR was installed at NUST by Professor Sher Jamal Khan when he returned after his PhD. And by the help of research for 6 years, they were able to go up to 50 meter cube per day MBR installation at NUST in 2014. And that MBR is R&D based MBR and treating the domestic sewage generated by some apartments, which is a very partial flow of NUST. But this MBR, you can do R&D, you can turn off and turn on different unit operations and processes and do your research. So research areas in MBR, this part is specifically for the students. After looking at the last few slides, you will think, okay, so which areas I can really work for my research? There could be many areas like wastewater to be treated, membrane characteristics, attached growth material, microbial properties, optimization, and anaerobic MBRs. We will discuss all of them one by one. Wastewater to be treated. So MBRs have been proven effective for most of the wastewater types, like for hospital, dairy, textile, but still there could be some type of wastewater streams which are either not like so far tried or attempted by the researchers, or someone attempted it but was not successful and they cannot identify why it was not successful. So in Pakistan, luckily we have roughly all type of industries, and if you if you do a good literature review, you can always find that what kind of wastewaters are not really attempted and what we can do in our research. Membrane manufacturing is also one of the area. I know some of universities in Pakistan, they have the capabilities to develop membranes, but generally the membranes are developed. They are countries which are very good in membrane development research are China, South Korea, Japan, because all the big companies, even I showed you, they are based on those countries. Singapore, they do more research on membrane development. So Pakistan generally do very less research on membrane development, but that can also be an area for chemical engineers or material engineers. Attached growth material you see here in the MBRs. So these plastic media are moving around. They are called attached growth material. So one is that your MLSS or bacteria hang around in the tank, like in these two tanks, without any sport. And one idea is to give some sport, some plastic media or any other media. So people have used different type of media, starting from styrofoam to this kind of cardinous media. What they do, the bacteria attach to the media surface, and the inner surface of this sludge layer is anoxic in nature because air is not reaching the bacteria in the very dead zones. So this, when you have this kind of media in your MBR aeration tank, it can give you aerobic treatment, also anoxic treatment, because those bacteria are kind of in an anoxic mode, which is kind of aeration star mode, and they can do a bit of treatment for nitrogen and phosphorus removal. So you can try other type of media as well. Type of bacteria. We found in our research that generally the dominant species of bacteria in the MBRs are E. coli, Pseudomonas aeruginosa, Nitrosomonas, and people also tried to have a monoculture MBRs in which they targeted to remove certain specific contaminants from their wastewater. And for that, they find that this kind of bacterial species is more effective. So we don't want to grow the other species. So they went with monoculture MBRs as well. Although their operational difficulties are a challenge, but that is also a solution. And then you see a small word I wrote here, quorum quenching or quorum sensing. These are also latest technologies in which, because these bacterial exudates are, or their excreta is the main thing which is causing the, they are used as a gum to stick all the contaminants on the membrane surface. So now people are trying that these bacteria don't interact with other bacteria, and then they don't release that much exudates, which is used as a gum for contaminants. So that process is called quorum quenching, and it is now the research in the town. Optimization of processes. Although for MBR, processes are well optimized, that what kind of filtration mode you use, what when you should do, and how frequent you should do backwash. But as going to option number one, if you have a brand new stream of wastewater, probably you have margin to do some optimization of process studies. And then anaerobic MBRs and gravity-driven MBRs. There are also MBR which have no aeration. As we saw, the 53% of the energy of MBR was used in aeration. So if I don't want to do aeration, I can use it as an anaerobic MBR process. If, of course, it will have lesser energy requirement, but also its effluent quality would not be very good, and it would generate far less effluent compared to aerobic MBR. And then there are gravity-driven MBR, in which the membranes are submerged inside the tank, and gravity is used, so that because membranes, these ultrafiltration membranes, they operate around 1 or 2 bar pressure. So if your gravity tank is very tall, it can generate a hydraulic pressure of 1 to 2 bars. So your membranes can get outside infiltration, and you can get effluent. So these are also one area of research. So now a case study of membrane bioreactor at Pakistan Kidney and Liver Institute, Lahore. This MBR was designed and installed when I was working in my last job as Manager Environment and Public Health Engineering at Infrastructure Development Authority, Punjab. So PKLI is a flagship project of Punjab government, last Punjab government to be exact. So before that, people were going for kidney and liver transplant at least to India or to America. Of course, going to America was expensive, and going to India was difficult due to visa processing issues. So this is really a gift for those people who can find a donor for kidney or liver transplant. So it's a big facility, and it is already like partially completed and partially under operation. It has 800 beds in the DHA phase 6. Lahore, it has a 800 bed, and it will be extendable to 1500 bed with 100 ICUs, several OPD department. It's a big facility. So we estimated the wastewater of this facility to be 1600 meter cube per day, and the MBR was selected as the treatment technology due to several reasons, because it's the state-of-the-art project of Pakistan, so it should have also have the state-of-the-art wastewater treatment plant. So total flow of 1600 meter cube per day, we divided it into two modules of 800 meter cube per day each. The reason for this is because when you have a hospital or a housing society or anything which you can not foresee that it would be completed or fully operational in like 1-2 years, it is always wise to install your plant in different trains mode. Okay, so that if it is partially operational, you are getting a partial wastewater flow, you can run one train. So when your flow would be full, you can run the second train. So it is fully operated through SCADA system and well designed. That's its 3D model. It has belt filter press for sludge dewatering as well. And that's me and Professor Shehjamal and some experts when it was under installation at the site. So effluent characteristics, we use the water, treated water from this MBR would be used for horticulture requirements of the PKLI, Pakistan Kidney and Liver Institute, and their characteristics are selected as per US EPA requirements for horticulture reuse. Very important factor whenever you will serve as an environmental engineer, you should know operation and maintenance is an integral part of any project success, particularly when it is a government project. But we see many failure projects of, I don't want to take the name, but like VASA or others, because they don't consider operation and maintenance. They think that they can handle these things themselves once the contractor will install these things. But to be honest, in many of the time they don't have the expertise, and due to those reasons the plants need maintenance. Of course, they are mechanical and electrical things. So for project success, you need to put a good operation and maintenance, and you can sublet it to the same contractor or some other consultant or company which can run your plant. So yeah, in the left side you see a couple of MBRs installed here. That was me and this Dr. Chung and his students and some faculty members in FC College, University Lahore. And then the right side you see MBR plant lab scale research going on in GUT Texas. So these are some of my papers which I have published in the area of MBR in different years in different journals. Many thanks for your patience. And if you have any questions, please do not hesitate to ask. I'm now stopping the sharing of my presentation.
If you have any questions, you can write in the chat box or you can unmute your microphone and can ask. Thank you so much. It was such a nice presentation. It was such an informative session. We've learned a lot. But there is one question in the chat box, and it's a very general question that do you have any idea about the few importers who are importing such membrane in Pakistan? And one example that you have already given, that is a plant that is installed in Pakistan. Do you have any examples of MBRs that are installed in Pakistan at different locations?
Hmm. That's a question which always comes after the presentation, that how many MBRs or where they are installed. As I said during the presentation, we like generally I want to use the word bhed chal in our country, that we generally think only those things more credible which have already been installed by others. When it comes to industry, I'm working with some industries as a consultant as well. We know the MBRs are effective, but because no one else have installed, so they don't want to be the early bird for these kind of treatments, and they don't want to take risks. But inshallah, once people will start, like I did in my previous job, so when people will see successful applications, so these things can boost very easily. And second thing, that also answer your other part of question. For membrane, there are many companies which I have given in my slides. They are the top companies which are manufacturing membranes, and you can directly get the membranes from them. You don't need any supplier. There are some authorized representatives as well, uh, which are getting membranes from them and supplying you in Pakistan. But of course, you can directly get from them as well.
Sir, I have a question.
Yes.
Sir, I want to ask you that where will we discharge the chemical we use in cleaning of membrane?
Very good question. Generally, the membrane cleaning is done by sodium oxychloride, which is bleaching as well, bleaching solution, or sodium hydroxide, or HCl, or a series of all three chemicals as specified by the membrane manufacturer. So purpose of telling these chemicals is that all of these chemicals are not very toxic because they are used in very dilute concentrations. Like we use something like 0.3 ppm concentration of sodium oxychloride. When much more than concentration we discharge in our drains when we do bleaching at our homes and other activities. So just unfortunately, we have to generally we drain these chemicals. but that is very less frequent. Chemical cleaning only happens once a month or once in 2 months, not more than that.
Okay, sir, I have a question.
Yes.
Can you hear me?
Yes, yes, Isan.
Okay, sir. Basically, can you please tell me that what is the operational cost of per liter of this treated water? And if, for example, we can sell this water which is treated through this MBR technique, so would it be favorable and advantageous for us? I mean, would it have a payback period quick, just installing this capacity and consuming money over it? Thank you.
A very good question, and the answer is that it depends upon which city you are currently living in Pakistan. For example, when it comes to wastewater treatment and reuse for industry in Karachi, the payback is generally in 1 to 2 years. The reason, because Karachi water is very expensive, so they always want to reuse their wastewater. But when it comes to Lahore, Vasa rates of water are very cheap, and most of the industries are drilling water and they are extracting from the groundwater sources, and they are just like paying their own cost. And per liter cost by Vasa is very small. I don't remember the exact number. Then the feasibility for reuse cannot, you are getting my point, then the return period or return of investment ROI would be maybe 10 years, 12 years. So in Punjab, currently with the current EPD rules, Environmental Protection Department and WASA rates, things are not feasible on paper. But from the other point of view, that if you have been given a target to treat and meet the standards, not by any cues of Pakistan, but by, I work with textile industry, they have to follow the guidelines provided by their client to whom they sell their products. And those guidelines cannot be met until you have something like MBRs or activity sludge followed by a tertiary membrane filtration treatment. So in that case, even feasibility of operational cost, if you say, okay, I am drilling fresh water, for example, in 2 rupees per liter, and my treated water cost is 10 rupees per liter, why I need to treat and reuse? Okay. So that kind of question you can ask. And in Lahore and in Punjab, generally return of investment is not good. But in Karachi or cities where you are buying fresh water with tankers, it is always feasible and more economical.
Thank you for such a detailed explanation of the question. One question from Gulfam Shoaib is that what is the future scope of using, I think, composite membranes, nanoparticles based membranes in MBR?
Okay, so very good question, and it again depends that what type of contaminants. I'm not a membrane expert, to be honest, and I'm just a user of membrane, so I cannot comment on. Generally, the membranes which are currently in use in MBR are also composite membrane. We call it thin film composite membrane. We are also using thin film composite polyamide membranes which has a polyamide active layer and a polyether sulfone support layer. So they are in use. And as I told, or as I showed you in a slide, the major difference in MBR operational cost can be brought down only by membrane. And the major difference which has already been brought down was mostly on the membrane-based research. So if we can have a membrane with the highest flux possible and with least contamination, or least fouling requirements or least cleaning requirements, of course, that's the challenge. So people are now doing research on graphene-based membranes, which are somehow very active in the research nowadays and are proving good for, they have very high rejections as well as they have very high flux.
Thank you so much for explanation. The next question is that when the transmembrane pressure rises, how could you determine that the problem is because of scaling or either is because of biological fouling?
Okay, transmembrane pressure measures the pressure across the membrane, and which you are monitoring through pressure sensors. They are giving you value. And in some case, if you do automation, they can give you a buzzer when the maximum transmembrane pressure is reached, after which you have to do membrane fouling. Now your question that how we know the transmembrane pressure increase is due to scaling or biological fouling, to be honest, transmembrane pressure cannot tell that what is the reason. In any way, transmembrane pressure can tell you only that this is the time to stop the membrane filtration and do the backwash. It cannot identify the reason for fouling.
That's interesting. I think if you have like, we can take two or three more questions. If you have
Yes,
more
of course,
questions, you
no
can
problem.
ask. If you have any question, you can ask. You can write in the chat box, or you can open your microphone and stuff. Yeah.
I think questions are finished now. Okay.
Yes, sir. So thank you so much for such a nice presentation on membrane bioreactors, and I hope that I wish everyone a very blessed day today. And thank you so much for joining. Thank you so much.
Thank you. Allah Hafiz.
Okay. Allah Hafiz.